everyone. Welcome back to my AP Calculus AB Unit 6 review. And this is Unit 6. And today we will have 5 problems to help you review for AP Calculus AB Unit 6. And so the first problem is write and solve the definite integral below in left Riemann sum with 15 subdivisions. So recall that the definition of left Riemann sum is the sum from I equal to 0 to n minus 1 of f of a plus b minus a over n times I times b minus a over n. So remember that n is number of rectangles and a is the lower bound, which is 2, and b is the upper bound, which is 5. So let's see. We take the sum from I equal to 0, n minus 1, there's 15 subdivisions, so it's 15 minus 1 equal to 14. The function f is sine squared. A, which is the lower limit, is 2. Plus b, the upper limit is 5, minus a, which is 2, over n, which is 15. Multiply by b, which is 5, minus a, which is 2, by n, which is 15. So this is the sum from I equal to 0 to 14 of sine squared of 2 plus 1 over 5i times 1 over 5. And now you can use a calculator to evaluate this and can get approximately equal to 1.438. And the actual answer for this definite integral is actually 1.4468. And this result is really close to the actual value. And now let's about a second problem, which on the first fundamental theorem of calculus. So solve for h prime 1 if h of x equal to the definite integral from 3x squared to x cubed of square root 16 minus t squared dt. So what we're going to do is to rewrite it. So h of x is equal to the definite integral from a to x cubed of 16 minus t squared dt minus in definite integral, the definite integral from a to 3x squared of 16 minus t squared dt. And now we can take the derivative of it, solving for the h prime 1, the derivative function, and we can use the difference rule. So that's x cubed 16 minus t squared dt minus the derivative of a to 3x squared 16 minus t squared dt. So now we can evaluate this. So that's, we can substitute x cubed first. So that's 16 minus x to the 6. Don't forget our chain rule. We have to multiply by the derivative of x cubed, which is 3x squared. Minus, let's substitute 3x squared in. So that's square root of 16 minus 9x to the 4th power multiplied by the derivative of the upper limit 3x squared, which is 6x. And that's h prime of x. And now you can substitute 1 in. H prime of 1 is equal to 3 times 1 squared, and square root 16 minus 1 to the 6th power, minus 6 times 1, times square root 16 minus 9, times 1 to the 4th power. So that's equal to 3 times square root of 15, minus 6 times square root of 7. And that's the result. And now let's talk about the second problem. We need to solve this definite integral from 0 to pi over 4 of tangent of x times secant squared of x dx. So what do we see here? Is that there's a tangent of x and secant squared of x. If we take the derivative of tangent of x, that's equal to secant squared of x, which means that we have to use U-substitution to solve for this. So let U is equal to tangent of x. Du is equal to secant squared of x and multiplied by dx. And now we can substitute in. So that's equal to an integral of U du. And don't forget we have to change our limits according to the U function. So the upper limit is tangent of pi over 4, which is equal to 1. And the lower limit is tangent of 0, which is equal to 0. So now this whole integral becomes from 0 to 1 of U du. And now using reverse power rule, we can get it's equal to U squared over 2, evaluating from 1 to 0. And using the second fundamental theorem calculus, we can just substitute 1 in and minus substituting 0 in. So that's 1 squared over 2 minus 0 squared over 2. That's equal to 1 half. 1 half. And that's our result with this problem. Now, here's the fourth problem. We need to calculate this indefinite integral of 3x squared plus 5x plus 3 divided by 3x minus 1. You should first try to simplify this, but we do see here that there is a minus sign in the denominator and there's all positive sign in the numerator, which means that we cannot factor this. So we're going to do, we're using something called long division to evaluate this. So we're going to do is to divide this expression 3x squared plus 5x plus 3. We're going to divide by 3x minus 1. Let's see what we do here. We can multiply by x. So we get 3x squared minus x, minus 1x actually. So that's 6x plus 3. And we can do x plus 2. So that's 6x minus 2. That gives you 5. So this integral gives you the indefinite integral, indefinite integral of x dx plus the indefinite integral of 2 dx plus the indefinite integral. You see, we have a remainder here, and we can write it 5. Oh, we forgot the integral symbol. 5 over our denominator 3x minus 1, 3x minus 1 dx. Now we can use substitution to solve for this. It's not so obvious you can use substitution, but if we say that u is equal to 3x minus 1, and let du is equal to 3, we see we have a 5 here, we don't have a 3. What we're going to do is to write this integral 5 over 3x minus 1 dx. You're going to write it as 5 times the indefinite integral 1 over 3x minus 1 dx. Now we can put 3 in. 5 times 3 over 3x minus 1 dx. But we have a 3 here, making the equation not equal to the previous one, so we have to multiply by 1/3 outside. So now we can do the u substitution. So we can say that, actually let's simplify this. 5 over 3 times the indefinite integral of 3 over 5x, 3x minus 1 dx. So let's write it. So that's equal to 5 over 3 times the indefinite integral of du over u. What is this equal to? Well, that's 5 over 3 times the natural log of absolute value of x. And don't forget the plus c. Now we solve for this. We solve for the third term. I'm gonna move this u away. Solve for the third term. Let's solve for the first and second term. The indefinite integral of x, the x is x squared over 2. We're increasing the exponent by 1 and dividing by the new exponent. Plus 2x, we're adding an x for constant. And plus, where we just evaluate 5 over 3 times the natural log of absolute value of x plus c. And this is the indefinite integral of this expression. And the last one, we're taking the antiderivative of this indefinite integral. So this is a 1 over square root problem, which means that we can use completing by square to solve for this. So what we're going to do is to complete the square. So that's 1 over square root of, let's see, we can minus sign x squared minus 12x minus 32. I'm going to extend this dx. What is this equal to? Well, don't forget we have to complete the square. X squared minus 12x. What are we going to do? We will divide this by 2 and square it. So 16 over 12 over 2 squared equal to 6 over 2. 6 to the second power, which equals to 36. So into plus 36. And to make it equal, we have to multiply by the coefficient of the minus this value. The minus 36 times minus 1 equal to 36. So what we can do is we plus 36. And don't forget our minus 32. And dx. These two are completely equal. And now we can take the definite integral of square root of 4 minus, we can write this as x minus 6 squared. And what we're going to do next is to factor out the 4 here. Or you can just directly use the equation of, we can directly use the equation of arc sine of u over a. But let's just use it first and then solve using the u substitution. So arc sine of the u is this whole thing inside the parentheses squared. So that's x minus 6. A is this value. However, it's the square root of this value. So that's square root of 4 equals to 2 plus c. That is our value. But let's use u substitution for this. So now we're going to factor our 1/2 equal to 1/2 times the indefinite integral 1 over square root. If we multiply this by 2 and we want to take off from the square root, we have to square it. So that's 1 minus x minus 6 over 2 squared. Why is this? Because when we distribute this inside of the square root, that becomes 4 times this value. And the dividing by 2 squared is just 1 over 4. So these two are equivalent. Don't forget the dx. So that's equal to Actually, let's use the U substitution for this. Let's say U is equal to x over 6 over 2, and du is equal to 1/2 dx. So which means that can put 1/2 times the indefinite row, 1/2. We put 1/2 here, so we need to multiply 2 to equal out everything. Root of 1 minus x minus 6 over 2 squared dx. So now we can substitute these u's. That's equal to the indefinite row of du over square root minus 1 minus u squared. And this is the arc sine. So that's equal to arc sine of u. So which can see the u is x minus 6 over 2. So that's arc sine of x over 6 minus 2 plus c. And that's our result. We see that's the exact same if we just stop here. And that concludes my review video for this 5 steps for AP Calculus. Please like and subscribe my channel, and we'll see you next time.